So the next speaker of the session is coming up to the stage now. Please welcome Johan Beck.
Hey everyone, my name is Johan Beck. I'm back here after 2 years since my last presentation where I talk about pluggable optics. So I'll give a brief update on what's happened since then. I thought by introducing Infin, not using the standard corporate slides, right? I worked for Infin for over 20 years. We build optical transport solutions. We're a one-stop DWDM shop. So most of the stuff that the previous Johan said went over my head because we work down in the layer 1 basement. It's really cool down there. We have light. I thought I was going to be the last presenter before lunch. I didn't look carefully enough. So that's why I thought maybe I will hear your stomachs growling a little bit. But you could say that optical transport solutions, they've been sold for forever, have been like a burger, right? You go to one store, you buy the whole burger, and you eat it, consume it. But it's made up of a lot of components, some, like the bun and the lettuce and the meat, right? Because the cool part is the meat. And at Infin, we make our own meat or non-meat. We're vertically integrated, so we start with indium phosphide wafers, and out comes an optical transport system in the end. So what are these components, right? What am I talking about? You have one thing called the line system, which basically you inject the light into it. The light comes out the other side, and hopefully it's good enough that you still can make data out of it, right? And these line systems come in multiple flavors and shapes. And then we have optical transceivers, which turn out to be coherent in nature these days. This pertains to how the bits are modulated to become light, right, inside the DSP. And these transceivers come in different shapes and forms. They can be embedded, larger things that you put in a chassis, or they can be new pluggables that I'll talk more about shortly. So modern optical solutions, they're open, meaning that operators can deploy open disaggregated solutions. I mean, this is similar to what's going on in a lot of the networking space. You look over at mobile radios, access networks, O-RAN Alliance, things like that, meaning that you can buy different building blocks from different vendors, and you need standardized data models and modular platforms to deploy this in a solution that fits the operator well, right? And this allows, eliminates vendor lock-in. There are all good reasons to do it. And this is something we've been trying to do down in the layer 1 basement for a few years. So line systems, I think here in the room, most people work in IP and not in optical. So you have a port in your router, and then you want to be able to ping the router on the other end of the link, right? And it doesn't matter if that link is short or long. But to us in DWDM, it makes a big difference whether it's across town or across the Atlantic. And depending on how long it is and how much capacity you want to put on that fiber, we use different types of technologies and building blocks, starting with passive filters that allow multiple wavelengths or colors of light to be multiplexed into the same fiber, so you get more data on that fiber, to very advanced, the latest things are called super C plus L band solutions, meaning that we can put more colors of light than ever and shoot longer than ever. There are cool amplifier types with Raman amplifications or EDFA, all these building blocks. But sometimes a line system is just a plain fiber pair, right, for a lot of applications. So when you have this line system, whether it's a simple fiber across town that you rent from Stokab or somebody else, or if it's a transatlantic cable, in the end, we're transporting data in the form of bits. And we need an optical transceiver that can take that bit stream, modulate it, and turn it into light, send it to the other side. It needs to speak the right language. Sometimes that's Ethernet, sometimes it's something very strange, old legacy format that we still have to support. I know the whole world wants to go Ethernet and IP, but I'm hearing like power stations, they use some old 2 megabit per second, very proprietary thing, signaling protocol that people still deploy today. So we have to have things like that in our portfolios. Another property of optical transceivers is that they shouldn't use too much optical spectrum, because fiber is expensive to deploy, and the last thing you want to do is dig more fiber, right? You rather put more capacity, if you need to, on the same fiber. So talking about capacity, right? It's been a journey. I showed this a couple of years ago, this deck. So it's just illustrating the trend of industry over time, like what's happened over the last couple of decades. 20 years ago, or in 2000, normal DWDM system could support 40 10 gig wavelengths. So a total of 400 gigabit per second on a dual fiber, optical fiber pair. That was state of the art for an operator who wanted to operate like a core network. And that's really grown by adding more channels and increasing the speed per channel. And this coherent transmission came along in 2009, 2010 timeframe. And it's just kept going, right? So this is where, I mean, I started in 2001 at Infin, and like things have just gone crazy since, right? And is it ever going to stop? I mean, this slide hasn't been updated in 2 years now. There's now 1.2 and 1.6 terabit wavelengths, and more is on the horizon, right? And what's not on this slide is, what's not on this slide is that everything has gotten a lot smaller too. So originally, like 400 gig, right? That was probably rows and rows of chassis. And today, 400 gig is a little plug, right? And we have 800 gig and 1.6 terabit plugs coming. So you wonder, right? How is this going to proceed? Is it just an infinite path to the horizon that we're going to keep walking down in an evolutionary fashion with more and more capacity on every wavelength? Or are we kind of in the woods now and at a crossroads where maybe we should think about taking a different path? And I think there's a little of both, right? So some of the industry will keep going on maybe the path to the left that looks a little more even, where we just keep adding more capacity to the same fiber. That's certainly going to be required for wholesalers. Amazon here probably need a ton of capacity on transatlantic links, for example. So that's a segment where it might be where it's worth still building a better and better and better transponder. But to the path to the right, maybe there's some other things we can optimize, like space and power. Technology has gotten a lot smaller. At Infin, we started building something called photonic integrated circuits from indium phosphide 20 years ago. That's what the whole company was founded around. And it's basically a little chip the size of a fingernail that at the time was 100 gig back in the day, and now we make 400 gig chips. And it never really mattered when the product was this big, right, for 400 gig. But it really matters now when you're building a plug. So this underlying technology, photonic integration, everybody building pluggables today do it in one shape or form. So we have these pluggable optics, right? In a sense, they're a lot like the client optics we've always had to operate for short reach distances. But now we have DWDM pluggable optics that are pretty good. And they use this coherent format, and they're available in QSFP-DD form factors. So basically, what used to be a full fridge 20 years ago, size-wise, is now the size of a finger, right? And what does that do? When things get smaller and cheaper, they tend to get deployed in a lot more places. If you think about what's happened in the lighting industry, not in the fibers, but in rooms, right? Look at how many lights are in this room, and think about what LEDs have done, right? You can have 100 years ago, you were happy to have one light bulb in a room. There's a fire station in California that has a light bulb that's been running for 100 years or something. Look it up. I think it's in Livermore. Now you walk into a room and there's like millions of LEDs because they're so cheap, they need so little power. So pluggable transceivers, right? Coherent pluggable transceivers, they're going to go a lot of places. And what do you need to make this technology pervasive? Well, first of all, it has to have sufficient enough performance to be used instead of a larger transceiver. Secondly, it needs to be programmable to fit the application you're in. So there's a tremendous evolution still in DWDM technology, supporting longer distances or more capacity, but also covering new use cases, so going over single fiber plants, or, for example, over PON networks. So many operators are interested in fixed and mobile access convergence. You run the mobile transport, high-speed enterprise services, and residential traffic on the same fiber infrastructure to save fiber cost. So if you're deploying GPON, XGS-PON, how about you add some coherent wavelengths on top of that in parallel to drive all like triple play of fiber optics? That's possible today with coherent pluggable transceivers, and they need to be programmable for the use case. Last of all, they need to be manageable. Like, you need to be able to control and set all these programmable parameters. So looking at performance, DWDM transceivers are certainly good enough today. At Infin we did some testing with Arelion. Anybody from Arelion here in the room today? Yeah, hey, thank you. It's a good collaboration. We did 1,800 kilometers on a link, and this is a very good link with very good amplifiers and very good fiber. The fiber itself is very good. But this is the kind of stuff you can do today with state-of-the-art pluggable optics. They don't have to come from Infin necessarily. I mean, there's some good pluggables on the market today. But management is a major challenge. And here are some words from Signal AI, who's covering the layer 1 industry. It's actually pretty complicated because we have this layer 1, this OSI model, right? So all of a sudden you take some layer 1 equipment and you put it in a layer 3 device. And that layer 3 device isn't necessarily used to managing those types of parameters that you have to set. So maybe you can configure it, but troubleshooting is complex. So, I mean, the whole model is based around ignorance is bliss, right? So if you work in layer 3, I think you should be happy to not have to worry about layer 1. And for us working at layer 1, we don't know much about layer 3. So that's why, the previous speaker, there's a lot of stuff I didn't get, or actually most of it, I must concede. So now what's happening, right, is that there's talk about IP optical convergence. How much time do I have, by the way? Lots of time. Okay, very good. You take layer 1 equipment, put it in a layer 3 device. Should we just get rid of layer 1 altogether, throw it away? You don't need it, we don't need it anymore? I mean, there's been talk of IP optical convergence for some time. I found this old press release from Ericsson 10 years ago. It was mentioned. And pretty much every vendor in the room is speaking of IP optical convergence in some sense. And I think absolutely, from a hardware architecture perspective, it's the right thing to do. But there are other challenges, operational challenges, organizational challenges. We have people used to working in layer 1, and we have people used to working in layer 3. And they speak different languages, right? Layer 3 people may be more used to typing things in a command line interface. Layer 1 people, they like to see network topologies and maps and GUIs, things like this. And even when it comes to fiber optic links, or when you think you're talking about the same thing, typically it's very different, right? Because it's one thing to do DCI or shorter connections across town, where you just look at what kind of attenuation you have in your fiber, and you pick the right, short reach and immediate reach, long reach or extended reach pluggable, and you say, oh, this is going to work, and it works, or most of the time. But at layer 1, there are amplifiers. So when you launch your wavelength, first it gets weaker and weaker and weaker as you go down the fiber, and then you go into an amplifier. and you boost the signal, and it starts getting weaker again. And when it comes out to at the other end, you want the right power level for every wavelength, and every wavelength is amplified differently. You also need to manage your signal-to-noise ratio, and there's a ton of parameters. So all DWDM vendors, they have design tools, they have armies of system engineers who will guarantee designs over life. So it's one thing to take a 400 gig ZR plug and run it across town. It's an entirely different proposition to run it across a country or nationwide networks of links and guarantee it's going to work everywhere. And you do this on a trial basis, it's a little complicated. So thinking back to the previous speaker, I think when it comes to IP over DWDM, in the sense that you're running IP traffic over a nationwide DWDM network, where like the EVPN services were 10 years ago. It's a bit immature, and people are dipping their toes into this. And Infin, as a DWDM vendor, we're trying to hold our customers by the hand and helping them out here. So what is so challenging? Well, you look at network automation, right? And if you deploy an orchestrator, and you have an optical controller, and the orchestrator says, I want more capacity from Stockholm to Malmö. It makes a request to the optical controller, and then the optical controller, in the old days, where there was an optical transponder that's as part of the layer 1 system, the optical controller would just talk straight down to the optical transponder and configure it, and everything would be easy. But now that the transponder or the optical transceiver is sitting in a layer 3 device that is not controlled by the optical controller, what does it have to do? Well, there are different solutions being discussed in different forums, but one solution could be jump over to the packet controller and then down into the router OS, and the router will then talk to the pluggable and configure it. And this becomes like a game of Chinese whispers. So not only so the optical controller needs to implement the information model or data model for the pluggable, and these are evolving over time pretty rapidly. Then it has to be implemented in the packet controller and in the router OS. And some people say this is easy, but there's some work going into this. Some people are shaking their heads here, and I know major router vendors, they will charge you for this because it's so much work. So maybe there are better ways to do it. So I think in one of the forums, is in a tip, one option is being discussed is that the optical controller can talk directly to the router, which is presenting like a nice model northbound. But maybe it's only read-only. It still won't commission things, right? So are there different ways we could do this, right? And I think layer 1 certainly is a very small piece of the overall ICT industry. So why don't we just look around and see how other parts of the industry have solved similar problems? Like I was saying, yeah, we may be 10 years behind EVPNs in terms of maturity, but when you look at microwave, what people have been doing in the radio world for 30 years, right? I think they've been very, very good at hiding complexity to the user. If you use a cell phone today, whatever you use it for, you get connectivity, you can make phone calls, but there's incredibly sophisticated transmission going on to the base stations, utilizing different frequency bands, using time slots. They've really done a marvelous job. Sweden is Ericsson here in Sweden, right? I don't know anybody from Ericsson is here, but certainly this whole industry has done a great job of abstracting a ton of complexity to the users. And maybe we should try to do the same thing for coherent pluggables, right? They should provide fiber connectivity transparently to the users. Just, if you want wireless connectivity, it's easy. You buy a little chipset and you put a SIM card in it, and wow, your lawnmower is online, right? Anybody have a robotic lawnmower that is like wired up? Yeah, at least one, right? It's easy to do. You don't have to configure modulation formats and which base station to connect to and all this. It's taken care of. You know, with coherent pluggables, it's not that easy, but maybe it should be. Another industry to look at is IoT. So you think of a coherent pluggable. It doesn't have a keyboard. It doesn't have a display. It has very limited storage and compute, electrical resources for storage and compute. So why not look at how that industry has solved the issue of provisioning, monitoring, maintenance, operations. Maybe even look at the software that's already available and deployed in millions of devices globally already. What could coherent pluggables look like, right? So we have built a coherent pluggable that works like other coherent pluggables in the sense that you can manage them the old dumb way, but they also have a little Linux stack inside supporting IoT protocols. You can install them in a router. They can get an IP address, even an IPv6 address, and they will automatically onboard using standard protocols into a little SDN controller. So it's a different way of doing things, and it allows basically the pluggable to talk directly to the optical controller and eliminate some of this Chinese whispers game. And deploying this, we demonstrated to customers today, and we work with a lot of industry players. We've formed a little industry alliance called OpenXR Optics Forum to try to standardize around this. Hopefully, we can all keep speaking our own languages. DWDM people can operate end-to-end networks and take care of all the issues, just like Telia and Telenor take care of all the, cell phone connectivity challenges without me as a user getting involved. And the IP community can continue to ping the router on the other side without having to worry about wavelengths and modulation formats. And just one thing that struck me, shaping means something very different in layer 3 and layer 1. So, we may even use the same words, right, for extremely different things. All right, so if you have any questions, come over to the Enlogic booth outside. Enlogic is our local reseller here in Sweden and Norway and in the Nordics, also in Denmark. So they can sell like a new type of disaggregated solution with some Infin burger inside of it, perhaps. And see you at the social tonight. I didn't bring any pluggables, but there will be drinks. Thank you. Any questions?
We have a question.
Yeah, the first question is from the internet, and it's about the security challenges that you are concerned about when introducing remote control capabilities into the pluggable optics.
So first of all, it provides a new tool that people can use if they like to. In terms of security challenges, what we hear from some customers is that they prefer not to hand out admin credentials to the routers to new teams like DWDM technicians and transport NOCs. So yeah, security challenges are abound, but by using standardized software that's robust and hardened from existing today, we think that it's better than we wrote all the source code ourselves. Yeah, it does become, we can even do layer 1 encryption, so the device itself becomes, like we have to manage what's called threat surface around the pluggable itself, so you can install it in a device that doesn't know anything about encryption, and we will make sure that link is secure, including the control plane, data plane, and management plane. Very important question.
There's a question over there, this side of the room.
Hi, Ben, BGP Tools. So you mentioned about like the hypothetical power plant that uses a weird 2 megabit standard.
Yes.
How do you fit that in line systems? It's more of I have a personal project which involves such interesting protocols, but you mentioned obviously you have things like ATM and SDH, presumably people still transferring stuff over that. How do you mix
that's
that
why, there's some RFPs, right? We talk about requirements, and some RFPs come in and it says you need to support this protocol, so we need a little device that basically encapsulates this and multiplexes it into a wavelength with a whole bunch of other things, abstracts, whatever's. Yeah, so we devices like this surprisingly are still needed. The whole world is not IP yet.
Oh, okay.
Okay. Any other questions? Okay. Well, please join me in thanking Johan for his presentation. Thank you so much.
Thank you.